integrate the integral from negative pi over 2 to pi over 2 of 4 cosine theta divided by 3 plus 2 sine theta d theta. First, I would bring out the constant. So 4 in the out front, the integral from negative pi over 2 to pi over 2 of cosine theta over 3 plus 2 sine theta d theta. And if you note, the derivative of the denominator is in the numerator. So I can rewrite this as an integral of 1 over u du. So let u equal 3 plus 2 sine theta, that's my u, and du will be 2 cosine theta d theta. So let's make everything in terms of u. So that will be 4, the integral. Those integrals, those endpoints are thetas. I will change those to u in a minute. So you have u in the denominator, and then cosine theta d theta is what is left. So solve this equation for cosine theta d theta, and that gives you 1/2 du cosine theta d theta. So 1/2 1 over u du. Let's look at our endpoints. I'm going to draw a unit circle quickly. That order pair is 0, 1. This one is 0, -1. Here I have 1, 0. And over here I have -1, 0. So this is pi over 2 at the top and negative pi over 2 in the bottom. So let's take a theta of -1/2. U equal 3 plus 2 sine of negative pi over 2. Well, sine of negative pi over 2 is a -1. So 3 plus 2 times -1, and that gives you 1. So I have a lower endpoint of 1. Upper endpoint, let's convert the pi over 2. U equals 3 plus 2 sine of pi over 2. Sine of pi over 2 is 1. So that will be 3 plus 2 times 1, which is 5. Upper endpoint of 5. So 4 times 1/2 is 2. And then the integral of 1 over u, that's ln of u, evaluated between 1 and 5. So that will be 2 times ln 5 minus ln 1. ln 1 equals 0. So your answer is 2 ln 5.